Hello everyone, welcome back to my channel. In the previous video, we had discussed a very important topic of DevOps, which is blue-green deployment. Today, we are going to discuss some of the very important questions based on blue-green deployment, which are frequently asked in the DevOps engineer interviews. So let's start. Question number 1, what is blue-green deployment? The answer to this is blue-green deployment is a deployment strategy that uses two identical environments. One is blue, that is live and serving the user traffic, and the other is green, where a new version of the application is deployed. Once the new version is tested in the green environment, traffic is switched from blue to green, making the green live. Question number 2 is, how does blue-green deployment work? The answer to this is, the process involves setting up two identical environments, one blue and one green. The blue environment runs the current production version of the app. The green environment hosts the new version. After the green environment is tested, traffic is routed to green. If issues arise, you can easily switch back to the blue environment. Question number 3 is, what are the key benefits of blue-green deployment? So there are three key benefits of blue-green deployment, which are zero downtime, easy rollback, and reduced risk. So for zero downtime, it is smooth transition between versions with no user interruption. Like the traffic transitions from blue to green very smoothly without any user interruption. Then comes easy rollback. If any issue occurs, then switching back to the old version is quick and simple. That is, switching back from green to blue is quick and simple. Then is reduced risk. Testing the new version in a separate environment reduces the risk of affecting the users. Since we are testing the newer version in the green environment, at the same time blue environment is already having the traffic in it, so it doesn't affect the blue environment. Question number 4 is, how does blue-green deployment ensure zero downtime during the deployment? So answer to this is, by keeping two identical environments, one is blue and one is green, you can deploy and test the new version in the green environment without affecting the users. Only after the green environment is fully tested and ready, traffic is switched over from blue to green, ensuring no downtime. Question number 5 is, what are the differences between blue-green deployment and canary deployment? The answer to this is, blue-green deployment and canary deployment are both strategies for deploying new versions of the software, but they differ in how they roll out updates and handle risk. For release scope, in case of blue-green deployment, the new version is deployed to a separate environment, green environment, and all the traffic is switched at once from the current, that is the blue version, to the new one, from blue to green. It's a full and immediate switch. But in case of canary deployment, the new version is gradually rolled out to a small subset of users. They are called the canary group. If it performs well, only then more users are gradually routed to the new version. It's not a one-time process. For rollback process, in case of blue-green deployment, rollback is easy. Simply switch back to the blue environment if something goes wrong in the green environment. In case of canary deployment, rollback can be more complex because only part of the user base is affected. You may need to stop or adjust the traffic routing because only one part of the user group has been diverted to the green environment. So rolling them back can be more complex. For risk mitigation, in case of blue-green deployment, risk is minimized because the entire environment is updated at once and the old version is kept intact for quick rollback. In case of canary deployment, risk is mitigated gradually since only a small portion of users are exposed to new version at first. For traffic flow, in case of blue-green deployment, all the traffic is routed to the new version after deployment with no gradual exposure, like it's done at once. But in case of canary deployment, traffic is routed incrementally to the new version, enabling more controlled monitoring and testing in production. In summary, blue-green focuses on switching environments entirely, while canary focuses on gradually exposing a new version to the users to identify potential issues before a full rollout. Question number 6, can you explain the concept of rolling back in blue-green deployment? The answer to this is, in case of issues with the green environment, you can immediately switch back the traffic to the blue environment, effectively rolling back the deployment. This proves a quick recovery mechanism. Question number 7, what are the components involved in a blue-green deployment strategy? The answer to this is, a blue-green deployment strategy involves several several key components to ensure smooth, reliable, and efficient deployment with minimal downtime. These components are: first is two identical environments, one is blue, one is green. The blue environment is live production environment where users are directed and the stable version of the application runs. The green environment is a new version of the application which is deployed here for first testing and validating before going live. The second component is load balancer. The load balancer plays a crucial role in routing traffic between the blue and the green environments. Initially, it directs all the users' traffic to the blue environment. After validation of the green environment, load balancer switches the traffic from blue to green. The third component is deployment automation. Automation tools like Jenkins, GitLab CI, or Argo CD are used to deploy the new version to the green environment, ensuring consistency and repeatability in deployments. The fourth component is database management, which includes database migration and data synchronization. So for database migration, when deploying a new version, any required database changes, for example schema updates, need to be handled carefully to ensure backward compatibility. This can be managed through automated scripts or migration tools. For data synchronization, in cases where the green environment requires real-time data, synchronization mechanisms are needed to ensure data consistency between blue and green environments. The fifth component is monitoring and logging. Continuous monitoring and logging tools such as Prometheus, Grafana, or ELK Stack are essential to track the health of both the environments, both blue and green, especially after switching the traffic from blue to green. They help in detecting any issues early. The sixth component is rollback mechanism. This is a very crucial part of the strategy. It allows quick switching back to the blue environment if the green environment shows issues after the traffic switch. This rollback is facilitated by the load balancer and the unchanged blue environment. The seventh component is CI/CD pipeline. The continuous integration and continuous deployment pipeline using tools like Jenkins, Circle CI, or GitHub Actions helps in automating the testing, building, and deployment of the application to the green environment. In summary, the blue-green deployment strategy involves two identical environments: load balancing for traffic management, deployment automation for consistency, careful database management, monitoring for performance tracking, and a rollback mechanism to ensure stability during the transition. These components work together to provide a reliable, low-risk deployment process. Question number 8. What challenges can arise during a blue-green deployment? The answer to this is, while blue-green deployment offers many advantages, there are several challenges that can arise during its implementation. The first is resource duplication. Maintaining two identical environments, one blue and one green, can be resource intensive, both in terms of infrastructure and cost. This can be particularly challenging for large applications as it may require significant resources to run both environments simultaneously. The second point is database compatibility. Ensuring database schema compatibility between the blue and the green environments can be tricky. If the new version requires database changes, these changes must be backward compatible with the old version to avoid downtime or data corruption. Managing data migration and synchronization without impacting the performance is also a common challenge. The third point could be traffic switching complexity. While the load balancer handles traffic switching, the process needs to be carefully planned to avoid issues like traffic split. The traffic split means where some users get the old version and the others get the new version. This is known as traffic split. Especially during the cutover, any misconfiguration or delay in switching the traffic could cause user inconsistencies. The next point is state management. For applications with significant user session states or data in memory, transitioning between the blue and green environments can cause issues. Ensuring that the session states or in-progress transactions are not lost during the switch is critical, requiring robust session management solutions. The next point is monitoring and rollback testing. Post-deployment monitoring is essential to detect any issues in the green environment. However, continuous validation of both the environments after switching traffic can be resource heavy. Additionally, rollback testing, which ensures a seamless switch back to blue, should be practiced to ensure the rollback mechanism works as expected during the real-world failures. The next point is cost overheads. Since both blue and green environments need to be up simultaneously, the associated infrastructure costs can be significant, especially for large scale applications. These costs need to be managed effectively, and in some cases, cloud based scaling solutions are required to optimize resource usage. The next point is third party integrations. If your application depends on third party services or integrations, ensuring that these external dependencies are compatible with both the versions during the transition can be difficult. There could be issues with API versioning or integration contracts that affect the deployment. In summary, while blue green deployment is an effective strategy, challenges like resource duplication, database migrations, traffic switching, state management, and cost overheads need to be carefully managed to ensure a smooth, risk free deployment process. Question number 9 is, how do you ensure that the blue and the green environment are identical in a blue green deployment? The answer to this is, ensuring that the blue and the green environments are identical is crucial for the success of a blue green deployment, as discrepancies between them can lead to unexpected issues during traffic switching. Here is how you can ensure the environments are truly identical. First is infrastructure as a code. Using tools like Terraform, Ansible, or CloudFormation, it can be ensured that both the environments are provisioned using the same code and configuration. This approach eliminates the human error, guarantees consistency, and makes both the environments replicable at scale. The entire infrastructure, including networking, load balancing, and storage, is defined in the code, so the environments are configured identically. The next point is configuration management. Tools like Chef, Puppet, or Ansible help manage application configurations consistently across both the environments. By storing configurations in version controlled files, for example YML or JSON, it can be ensured that any configuration changes are applied consistently in both the blue and the green environments. The next point is containerization. If using containerized applications, for example with Docker, we can ensure that both the environments use the same container images. With tools like Kubernetes or Docker Compose, we can create consistent, repeatable deployments where the environment setup, including network and storage configurations, is identical across both the versions. The next point is CI/CD pipelines. We utilize CI/CD pipelines such as Jenkins, GitLab CI, or Circle CI to ensure that same build, test, and deployment process for both the environments. This guarantees that the code deployed to the green environment is the same as the blue environment. Automated testing is part of the pipeline to verify that the environments behave similarly after deployment. The next point is database schema synchronization. Database changes such as schema updates or migrations must be handled carefully to avoid discrepancies. I use migration tools like Flyway or Liquibase to ensure the database schema is consistently applied across both the environments. Any data updates must be backward compatible and synchronized before switching the traffic. The next point is automated testing. I use automated testing frameworks such as Selenium, JUnit, or Postman to verify that both the environments behave the same. Tests are run after each deployment to ensure that the application works as expected in both the blue and the green environments with no functionality differences. The next point is monitoring and validation. Continuous monitoring by using tools like Prometheus, Grafana, or Datadog helps validate that both the environments perform identically under load. Any discrepancies in performance or behavior can be identified and resolved before the full traffic switch to the green environment. By combining infrastructure as code, containerization, CI/CD pipelines, configuration management, automated testing, and monitoring, we can ensure that both the blue and the green environments are as identical as possible, minimizing the risk of issues during deployment. Question number 10 is, what is the role of load balancer in the blue-green deployment? The answer to this question is, in a blue-green deployment, load balancers play a crucial role in managing traffic between the two environments, that is blue and green, to ensure a seamless transition and minimize downtime. Here is how load balancers function in this strategy. First is traffic routing. The primary role of the load balancer is to route user traffic between blue, and that is the current or the live version, and the green, that's the newer version. Initially, all the traffic is directed to the blue environment, which is the stable or the production version. After the green environment is tested and validated, the load balancer switches traffic to green from blue. The next point is zero downtime transition. During deployment, the load balancer enables zero downtime deployment by allowing traffic to be gradually shifted from blue to green. If issues arise in the green environment, traffic can be quickly switched back to blue, ensuring no service disruption and a smooth user experience. The next point is health checks and monitoring. Load balancers constantly monitor the health of the blue and the green environments through health checks. These checks ensure that only healthy instances are receiving the traffic. If the green environment encounters issues, for example crashes or performance degradation, the load balancer can automatically redirect the traffic back to the blue environment from the green environment. The next point is gradual rollout or canary releases. In some cases, instead of switching all the traffic at once, load balancers can be configured to route only a portion of the traffic to green, while the rest continues to go to blue. This allows for a canary release style of deployment, where the new version is incrementally tested with real users before full traffic redirection. The next point is simplified rollback. If the green environment fails after traffic has been switched, the load balancer makes rollback easy and quick. It can instantly redirect the traffic back to blue, allowing for a fast recovery without affecting users or requiring downtime. The next point is SSL termination and session persistence. The load balancer often handles SSL termination, ensuring secure communication between clients and the servers. It also manages session persistence, ensuring that users who are routed to one version, either blue or green, remain connected to the same version throughout their session, preventing inconsistencies. In summary, load balancers in blue-green deployment ensure seamless traffic management, high availability, zero downtime updates, and easy rollback, making them a cornerstone of the deployment process. They allow for smooth transitions between environments and help minimize risks during deployments.